Good evening, sir. Hello. Good evening, students. Hello, sir.
Yeah, hello, good evening to all.
Good evening, sir.
So, we are going to continue the topic on stacks and implementation.
Sir, your voice is breaking.
We have discussed some of the insert, delete, unstable. Is now that okay?
No, sir. No, sir. Still has a problem.
Hello? Problem? Oh my God.
Yes.
What happened?
Yeah. Now I think it's better.
That okay?
No, sir.
No? Okay. So maybe I'll another headset. Yeah, hello. Is that okay, ma'am, now?
Yes, sir. Yes, sir. It's clear now. It's good.
Yes. I think previously I connected net with another this one network. That's why internet is very poor at the time. Now it's okay. I think 41 Mbps, fine.
Okay. Please, sir. Please continue.
Yeah. Yes, I'm going to continue with this stacks. So I'll tell you the operations so that you can keep in your mind the insertion deletion operations. Based on that, we are going to implementation of the stacks operations. Okay. So what I will do, I'll take Paint. I'll give you just overview of this last class. Yeah. So my dear students, now I'm going to explain the stack operations. Okay. So stack, how we are going to insert the data into the stack. Last in, first out. Last in, first out. Okay. So this is a stack. If you want to insert any element into the stack, okay, by default, the stack is the, I told you two operations. What is that? Stack overflow, stack underflow. Okay. So when is stack overflow, when is stack overflow? So now assume that the size of the stack is 4. Assume that size is 4. Okay. That means you have given size array. So I'm going to implement the stack operations using array. Okay. So what is your maximum size? 4. Now, so for every stack, I'm using one variable to indicate whether the stack having the elements or not, right? There is a variable called top. So by default, top, what is the initial value of the top? -1. Okay. Top initial value is -1. Now, okay. So maximum size are given 4. So do you have any element into this? So parallelly, I'm explaining with respect to the program concepts also. It is not like theory. What are the logic we are going to implement? I'm explaining. So now the stack is empty now. Now tell me, can you insert the data into that? Yes, we can, right? So whenever your top equal to -1, what is this? This stack is empty. Whenever you are empty, you can insert the data, not you cannot delete, right? If your top equal to -1, can you delete the data from the stack? So even it is empty, there is no data. How can you delete? No deletion, right? When you are trying to delete the data from the empty stack, that condition is called underflow. What is that? Underflow. Fine. Okay, you should tell me what is overflow? Underflow. Okay, that means no data in that. You cannot delete it. When is overflow? When the stack size is full. When the stack size is full, at that time you are trying to insert another element. So at this moment, so far I have not inserted anything. Now, see here. Yeah, this is my stack. Okay, so you want to insert 10. Okay, simply I can say insert. You write it. Okay, insert. Otherwise, we call it as push. Push operation, right? Push 10. So where I want to push, see this index is 0, 1, 2, 3, right? So now what is your top value? -1. So before inserting, okay, where you have stored this value, assume that this value 10 is there in the variable item. Okay, when you are going to place and where you want to place, okay, this array name, assume it is A. Array name is A. Okay, so before enter the value into the 10, what I want to do, assume that your value is item, right? Your value is item. Okay, where you want to store your value, your item value, where you want to store? A of top. A of top. Okay, so top always indicates my location where I want to store. But actually, what is the top? -1, right? So before assigning, okay, before assigning your item value into the top, what you should do? You should increase your top value. Okay, your top equal to top plus 1. Top equal to top plus 1. Okay, so that is the logic, very simple one. Okay, so by default top value is -1. Now you want to place any item, you want to insert, this insertion operation we call it as push. What we call push operation. Okay, push. You want to push any value, what you should do? You should increase the top value. Now what is that? -1 plus 1, 0. So A of 0. What is A of 0? Yes, this is the 0 index, right? A of 0. What is our item? 10. Whichever element you want to insert, that is the 10 you have stored into this. Now you tell me next, push 20. What is the another operation? Push 20. You please write in the chart window. Push 20. What is my data? Push 20. Now this is your array, your stack. Okay, stack name in the program I can say stack. Instead of stack, now I'm using A. Okay, in the program I can say stack. Okay, fine. Already you have 0 index. It has something number 10. Now, what is your data? Your top value is how much now? This is your top. Now your top equal to 0, right? Now same operations I will execute. Then what is your top? 0 plus 1, 1. So now what is your top? It is 1. Your top variable is pointed to 1. This is your top variable, right? Top equal to 1. So then your item, where is your item? 20. Your item you want to store A of top, A of 1, right? So the value 20 will be stored here. like this. Fine. So similarly, we are going to, let us assume you have kept all the elements. Top 1, right? Now top becomes 2. After that, top becomes 3. Top becomes 3. Okay. Now what is your top? It indicates 3, right? Index 3. Okay. Index 3. Your top variable is pointed to 3. Fine. Now it is full, right? Why I can say it is full? Your maximum size you said 4. Okay. That means when you can say it is full, your top equal to, okay, size minus 1, right? Your top equal to, what is the size? 4. 4 minus 1, that is 3. So whenever your size equal to, top equal to size minus 1, size minus 1 nothing but it is 3. Your top is pointed to size minus 1, that stack is full. Okay. Now you want to insert some more element. Now you want to insert, okay, 50. Is it possible? No, right? So you will get the message called overflow. Okay, this is called overflow. That's it. Okay, overflow. So this is the 2 cases. Okay. Now you want to display. How you are going to display? From top, that highest value, right? You want to display from the highest value. What is the highest value? 40. So top equal to 3, top equal to 1, 0. Until that you have to display. For I equal to top, I less than or equal to 0, I plus plus, like that. I minus minus. Always you should decrease. Okay. So 40, 30, 20, 10 you can print. Now you want to remove. So now tell me which element you will remove. You want to remove. Which element you will remove? Can you remove 10 now? No, right? Whatever the top element is there, that is the only you can remove first, right? So that's why what I'm saying, whatever the element you inserted at the last, what is that? 40. That last element only you can remove first. So that's why this operation we call it as last in. Whatever you inserted last, that is first out. So this is LIFO operation. Okay, last in first out operation. This tags, whatever you insert last, that is going to remove the first. Okay, fine. Now let me run this program, then we'll understand clearly. So now, as I told you in the last class, so what is my intention? I am going to write this program as a menu-driven program. I'm going to write this program as a menu-driven program. That means I have 3 operations. One is insert. Insert means insert an element into the stack. Okay. And one is delete, or we can call it as, I can say simply insert operation, also call it as push operation, right? Push operation, pop. The third one is display. After inserting, after deleting, you should display, right? Then only you can understand. Otherwise, you can't see that whether the data is inserted or not. That is show. Finally, exit. These are the 4 operations, right? Always it should ask enter your choice based on the option you inserted. So that operation should enter, right? It should do like this. So like this kind of program we call it as menu-driven program. I'm going to do on stack. Okay. So menu-driven program on stack operations. That is the my task. Okay. Now we are going to write this program. Hash include stdio.h. I can say int main return 0. Okay. What do you want? So whatever the functions you are using, you can also declare those functions as a function declarations. What we can do? Okay, let's see. First, I'll start this. Okay, now I'm going to use various functions. That's why, what are the functions? Void push, and I can say void pop operations. I'm implementing this program as a functions. Okay, for display purpose, I'm using show. Okay, since I'm using functions, all the variables I want to declare as a global variables. If you declare within the main, this will be within the main. Say for example, outside I want to use in the push operation. In the push, I want to use the same array. So here the same variable you want to use within the main or another function also, right? At that time, I should declare the variables as a globally. My array name instead of A, I can say stack. Any name you can give, right? So how you can declare an array? Stack of 100. Either you can use stack or you can say ABCD, no issue. My array name is stack, anything. Okay. So I'm using something variables. Whenever it is required, I am going to tell you now. As I told you in the previous operations, what is your initial value of the top? -1, right? So I'm going to use initial value equal to -1. Okay. And for choice purpose, I'll use enter your choice. Starting itself, my choice value, I'll make it 0. Okay. Then size I'm going to use. Let's see if any some more variables are required, we can declare. Now enter the number of elements in the stack. So now you want to display something size. Okay. Enter the number of elements in the stack. How many elements you want? Like the maximum size of the stack. You can mention either you want out of 100, whatever the size you want, you can mention. Okay. That's why I'm using n variable. I'm going to store that stack size into the variable n. Okay. Fine. Now let's see stack operations. Now for as a menu driven, I want to get some kind of menu format. So simply I can print like some good manner like stack operations, some kind of menu model. I'll just display to the new line. It's coming to the new line, right? Now what are the stack operations you want? Yeah, one menu should be displayed, right? So that I'm going to write while choice not equal to 4. You are given choice 0, right? In the starting, to make the condition true, I given choice value 0. Okay. So choice not equal to 4. Yes, true. 0 not equal to 4. Condition is true. Then I will enter inside. So here I want repeatedly, it should ask, okay, you should choose any option, right? So I can say printf. Okay, I can say here, you can say select or choose your option, right? Select your option below. Select your option below. Okay, whatever the option you want, like 1 insert, 2 push pop, like that I want to do. Printf \n. I'll write everything in single statement. How can I write? I can say push operation. After this \n. Immediately the second operation is pop. Immediately I can say \n. The third one is, you can say show operation, and \n. You can say fourth operation is exit, right? So like this, you'll get all options: 1 push, 2 pop, like that, 4 exit. These are the stack operations I'm going to do. Now, where you want to store your choice, I'll take printf here. Ending also I'll put \, so that in the next line I'll get enter your choice. Enter your choice. Yeah, I'll take into the variable. Okay, into the choice. Already I have declared the variable, right? Scanf %d ampersand. You see, you try to observe while I'm typing. You should observe where we are reading the variable choice, how I'm writing the program. By default, the choice operation is 0. Now I will enter 1, 2, 3 or something. Okay, if my choice is 1, then it should the variable is having choice 1, right? Then immediately we should use, how can we do all the minute driven program? By using switch cases, right? So what is the switch? Switch off choice. This is very important program. Any program you can develop using switch cases. Okay. Yes. What you can do here, case 1. Okay. So if your choice is 1, this will be compared, and whatever you have written, this will be executed, right? Case 1. Okay. So under this case 1, okay, so you can write one function. What is that? Push. Okay. Yeah. Again, and case 2. Yeah. Case 2. I'm going to write pop is the function. My user defined function. When I say push, it won't run the enter the elements. When I write pop, it won't delete. I should write manually. Okay. These are all user defined functions I'm writing. So whenever you enter the choice 1, it will compare, it will move to 1 is matching with the choice. Yes. So this function will execute and stop. It won't execute case 2, right? So if your choice is 1, if choice is 2, it will run this one like that. Only one case will be executed at a time. That all you know using switch cases. Okay, fine. Case 3. After the pop, which function we have? Show. I want to run the show function. Then case 4. Which one you have? Another case 4. Case 4 you can use exit of 0. I don't want, right? So simply I can say exit of 0. If the user not selected any 4, there will be directly move to the default. Directly it will move to the default statement. Okay. Default. You can simply please enter valid choice. You can say printf, please enter valid choice. So for default, no need of break also. Okay. So until that it is completed, right? This is the minute driven program. Now switch completed, while completed. Yeah. So yeah, outside of the main, how I'm going to insert. Okay. In this, what is the function definition? Once it is matched, it will move to the push function. So your control will come here. If your choice is 1, your control will come here and it will be executed here. Okay. It will be executed and it will stop the program. So in the push, what I have to do? What is the push operation? When it is, I can enter the push whenever your top equal to your maximum size. If top equal to n, I can say it is overflow, right? If your top equal to n, it is overflow. I can say \n is overflow. The stack is overflow. That means stack is full. We can't insert. Stack is overflow. Okay. If your stack is not overflow, then only you can insert, right? So in the else part, I can say, okay. So you enter the value. Printf, enter the value. Okay, you just enter your value. So I'm going to read your value. Ampersand val. I just taken a variable, and what are the number you want to insert? That number I took in this variable val. Okay. Now where I want to store, I already told you top equal to top plus 1. Top value by default it is -1. In that immediately in the stack of top in this variable, I'll put your value. This is what we have discussed here. Okay. So top equal to top plus 1, of top equal to item. Okay. So instead of item, I use value. Okay. Like this. This is the way we can insert. So even I have inserted, how can you see whether the value is inserted or not? Until display, you can't see anything, right? So that's why I'm going to use void show. I'm going to use void show. So for while I'm displaying, what is I value? Previously we have used 0 onwards. Now your top equal to 3, right? Your top value 3. So now a of top, that is a of 3. Of that a of 2, a of 1, a of 0. In the reverse order you have to print. How can you print? Like I equal to 3, I plus I minus minus. Print a of I. Then I minus minus, a of 2. Then 1, then 0. Like this you have to print 40, 30, 20, 10. Okay. So that's why I'm going to do. What is your I value? I value is the top. Okay. Then until I greater than or equal to 0. Then shall I increase or decrease? Decrease. First top value, next second value until 0. Okay. You are going to print. That's it. F %d \n, sorry, the double quotes, %d \n, comma, stack of I. I'm going to print that value. Sometimes when your top equal to -1, that means in the starting itself there is no data. In the starting itself, no data. That is top equal to -1. Is there any data to print? Nothing, right? So I can say stack is empty. When the stack is empty, you can't print anything. Printf stack is empty. Yeah. That's it. Now we did display and show. Now you want to only small statements. Deletion. What is the another function? Now how many functions completed? If it is 1, push. If it is 3, show. Now if it is 2, pop. Then finally if it is 4, exit. So now what I will do? We have pop operation. So I'll write pop also only 2 statements. Very simple. Yeah. When it is underflow, what is the underflow condition? If the top equal to -1, double equal -1, you can say your stack is underflow. Stack is underflow. You can't delete. Yeah. If there is a data, then what you want to do? Simply else top equal to top -1. That's it. So you are removing the top. So why? Because you are printing the top value, top element onwards, right? So I will explain after executing this. So that's it. So this is the minute driven program. Let me save and I will again run it and I'll show you. .c. Okay, let me run this. Yeah, see, our program is executed successfully. Enter the number of elements in the stack. Enter the number of elements in the stack. That is what we have entered, right? I entered 4. Now see how you got like stack operations. Select your option below. Okay. So 1 push, 2 pop, 3 show, 4 exit. This is what we have given, right? Yeah, 1 push, pop, show, exit. Okay, fine. Now, which one? Push. Number 1, push. Now enter the value. Enter your choice 1, enter the value. Now I given 10. Now enter. Again, since it is in the loop, since I given until your choice is not equal to 4, okay, it is going to be executed. Okay, fine. Whenever I given 4, then 4 not equal to 4 false, it will stop. Okay, enter your choice. Again, I will say push. Enter the value 20. Again, I will say, okay, enter your choice 1. Enter the value 30. Okay. Now, do you want to see so far whatever you have inserted? You want to see? So which option I have to see? 3. Enter your choice 3. See, do you got the output? 30, 10, 20, 10. Whatever you have inserted so far, by selecting the choice 3, I just displayed like the same manner. 30, 20, 10. Whatever the last you are displaying, first last inserted, first displayed, right? 30, 20, 10. Immediately it is asking again, select your option below. Okay, I'll do one thing. I will show you all the possibilities of errors, like is that overflow, is that underflow? Tell me, what is your size? You mentioned 4, but I'll try to insert 5 elements. Let's see what happened. Now I will insert one more element, 40. Okay, again I'll try to insert 5th element. Enter the value 50. Now see what is, I think, yeah, enter your choice. 3. Yeah, we have given top equal to n actually. Okay, it should be top equal to n minus 1. Okay, yeah, let it be. Okay, if the top equal to n minus 1, then I can say this will be stack is overflow. Okay, anyhow, even though I have given, it won't permit now, right? Again, 1. Yeah, see, again you have given push, then you got the message, stack is overflow. Previously I given equal to n, right? So that's why 0, 1, 2, 3, 4 it's showing. So now it is showing stack is overflow. Are you clear? Stack is overflow. Now, then stack it out. Control C. I'll stop this program. Yeah, I'll save. I'll run this program. Yeah, enter the number of elements 4. Then I'll show you other operations. 1, enter the value 10, and another operation choice 1, enter the value 20. Now the choice is 3. I got 20 and 10. Now we need to pop. We need to apply the pop operation, right? So now we have 20 and 10. So I will select 2, option 2. Enter your choice 2. Select your, enter your. Yeah. Okay. So by default, it will be removed. Okay. Whenever I say pop, it will be removed. How do you see? Okay. I'll ask the choice. When you show, then only you can say whether it is removed or not. I'll show you. Enter your choice 3. Now, what is your output? You have only 10. Do you understand? So previously we have 20 and 10. Whenever I just selected pop, automatically that is removed the top one. Now, how do you know whether it is removed or not? Again, you should select option 3. Then only you can say the rest of the elements are 10. Okay, fine. Now, again, I will select pop. Again, I select pop. Again, I'll show you 3. Any elements are there? No. What is the output? Stack is empty. You got stack is empty and I have shown stack is full. Now option 4 is for exit. That's it. Option 4 is for exit. Yeah. Is that clear for all of you? Is that clear? So this is stack operation, stack implementation using array. Okay, monitoring program on stack operations using array. So using linked list also we can do. We'll see at the time of linked list concept. Okay, without knowing linked list, you can't do implementation using stack. Now let us move to the another topic called queue. So now we'll move to the another topic, queue. Yeah, same thing I have shown. What is the push? Okay, value top equal to 1. Okay, when you enter push 20 top equal to 1. When you push top equal to, then it will store into the 0, 1, 2 location like this. Then stack is full. This is the push operation, pop operation, right? When we can say it's a pop operation, if you are trying to delete the element from the empty stack, then the condition will occur. What is the condition? Underflow condition will occur. That means once the pop operation is performed, top value is decremented by 1. When you insert, top is incremented by 1. When you delete, top is decremented by 1. That's it. Very single statement. Okay, fine. So top equal to 3. When you apply pop operation pop 40, then automatically your top variable is decremented by 2. See 0, 1, 2, 3 is the top. Now when you apply the pop, top becomes 2. After that, top becomes 1, top becomes 0, then top becomes -1. Top is -1, nothing but it is an empty. Okay, now let us move to the topic called queues. Okay, a queue can be defined as an ordered list which enables insert operations to be performed at one end. So all the insertion will be one end, that is called rear end. And delete operations will be performed at another end called front end. So the back side, yeah, rear end we call the back side, right? So rear end will be inserted and front end will be deleted. How we are going to see now? Queue is referred to be as first in, first out. Whereas stack is last in, first out. Whatever the last element you inserted, that will be deleted first. Whereas here, whatever you insert first, that will go first, go out, right? So this operation we called as FIFO, F5, FIFO. Okay, first in, first out. Okay, for example, people are waiting in a line for a rail ticket, form a queue, right? Okay, whoever is coming in first. So you are, waiting for the railway tickets or movie ticket. Whoever entered in the queue, he will go out first, right? Like that, he will take the ticket and he will go out. So you tell me now, you just keep in your mind, okay, in the ticket counter, whoever is inserting, where he is inserting, assume that in the last side, okay, he is simply moving the first. You just assume the ticket counter, right? From the rear end, he is inserting, he moved to the until the counter. After that, after taking the ticket, he will go from the front end, right? Same thing. Okay, enter the back end, and after collecting the ticket, he will go out from the front end. You just assume how we are collecting the tickets in the railway station or in the booking movies tickets and wherever it is, right? Same concept we are applying here also. Yeah, see, simply assume that this is the queue. Okay, here we have a ticket counter. People are inserting like this. They are coming in the rear end. They'll insert here, right? First. After that, another person will stand here. Third person will stand here. Fourth person will stand here. Fifth person will stand here. Who will complete first? Whoever is coming in first, that will take and will come out. So this is the way insertion will be at rear end and deletion will be done at front end, right? Yeah. Now try to understand there are 4 types of queues. Okay, we won't discuss all in detail. In the implementation, we'll do 2 queues. Okay, linear queues as well as the circular queues. I will try to implement. Now, what are the various types of the queues? We have 4 types of the queues. One is simple queue. The second one is circular queue. And there are some disadvantages in the linear queue. I'll tell you more in detail about the circular queue during the execution time. And the third one is priority queue. Whoever is coming inside, those who are having urgent emergency and priority, those will execute first. That will be there in this operating system also. And then the fourth one is double-ended queue, DEQ. We call it as DEQ. These are all various types of the queues. Now I'll give you small examples for all. Okay. Yes, that's why in the stack it is a linear. So that's why in the array operation, how we are inserting. Okay, if you want more than one element at a time, not possible, and we are inserting one after the other only. Okay, one after the other. Why? Because every integer location can occupy 2 elements. If you insert 10, 20 at a time, nothing but what? 2 separate locations you have to insert. Okay, so Anirudh. Yeah, that's it. I think the remaining all no other doubts. And let us move with simple queue or linear queue. Okay. Yeah, what is a linear queue? In linear queue, an insertion takes place from one end while the deletion occurs at the another end. What is that? Okay, the end at which the insertion takes place is known as rear end. See here, the rear end is the insertion will do here and deletion from the front end. Okay, and at the end in which the deletion takes place known as the front end. It strictly follows the FIFO rule. First in, first out. First value will be moved here, right? So you are inserting first in the rear only, but it will move and it will stand here first. After that, second value inserted and it will be queued here, and third, and then fourth, like this. You just assume like that, okay? Yeah, from the rear only, you are moving to here, okay? Fine. So always who is pointing your insertions? The rear value, okay? So now you tell me how many elements you have inserted so far. Okay, 4 elements. So your rear value will be incremented always. Now, have you deleted anything? No, right? So that's why front will not be any updated. Okay, so that we'll see what is that rear end value by default. I will keep or equal to -1 and f equal -1. At the time of inserting, I'll make both are 0. These are all we'll do during the programming style. Okay, so now I'll give you first different 4 types of queue operations. What is going to be each and everything. That's it. Next, circular queue. I'll explain more in detail in the next during the after completion of the linear queue. The disadvantage also. See, sometimes, okay, in the circular queue, all nodes are represented as a circular. It is similar to the linear queue, except that the last element of the queue is connected to, okay, last element is connected to the first element. It is also known as ring buffer. Okay, and as all ends are connected to another end. So why I'm using like this? What is the purpose of the using circular queue? What is the disadvantage of the linear queue? That I will tell you. Okay, actually what happened after inserting the queue will be full. So okay, the rear pointer is full only, but after deleting, okay, front pointer will be moved. After deleting, some more elements are vacant are there, but your queue will show the full. But even though you have the memory, even though you have the empty space, but queue returns the full. That is a disadvantage. At the time, if you follow the circular queue, you can avoid such problems. I will explain more in detail after completing one by one. Okay, fine. I'll move to the next one. In this priority queue, it is a special type of queue in which the elements are arranged based on the priority. Okay, so that means what? So whatever the variable having some priority, the special type of queue data structure in which every element has a priority associated with. While entering the data, I will give something priority also. So based on the priority, and those data will be inserted. Generally in the operating system, okay, whatever the execution processor having high priority, those high priority things is going to be executed first, after that followed by the least priority. So if you see here, okay, so all the elements will be arranged here. Okay, the first element is nothing but it is high priority, followed by next level priority like this. So decreasing priority order like this. Okay, inserting the queue here, deleting the queue here. Okay, so this is also follow the FIFO principle only. Okay, fine. So this kind of inserting the element based on the highest priority first. So those queues will be called as priority. Your operating system will work as a priority based only. Fine. There is another kind of queue that is called DEQ, nothing but double-ended queue. What is that? Double-ended queue. Okay, in the double-ended queue, insertions and deletions can be done from both ends. Either you want to insert and delete at the rear end, and you can insert and delete at the front end also. Okay, that is the thing. And again in this, you can find out there are two submodels. Okay, one is input restricted double-ended queue, DQ. Input restricted, that means what? Input restricted. You can insert, okay, input restricted. That means insertion operation can be performed at only one end. See, if you observe in this diagram, insertion will be only one end. Why? Because input restricted. I don't want two times. Input I will be restricted from only one time. Okay. But whereas input restricted nothing but deletion will be, I can do it both ways. But I have restricted input. I'll do only in the front end. I don't want in the rear end. Similarly, you take in reverse. Output restricted. That means what? Okay. That means I can insert both ways, but deletion will be done at rear end only. Like that, I can restrict the output. That means deletion. So this is another model under the double-ended queue. Okay. Now, let us explain in detail about the queues with the program. See, for your understanding, this is not a linear queue, this circular queue. So you can understand like this. Otherwise, I'll show you. I'll do operations. Yeah. So assume that this is the queue. Okay. Now this is empty queue. How do you say it's an empty? So always I'm having, okay, front and rear. By default, front is -1, rear is -1. Front is, I am explaining now with respect to program. Try to understand with respect to programming logic. Okay. So this is my queue. Now my array, this is also an array, right? So array name is like queue. I'm using queue. Okay, fine. So you have empty queue now. Okay, can you delete empty queue? No, I can't delete, right? Since it is under flow only. Okay, fine. If you insert an element, now I'll show you another operation. If you insert an element into the queue, okay, what is the element? That is 10. How you are going to be inserted? You are going to insert through the rear, right? You have to insert the elements to the rear. Now tell me, okay, your R value is, see here it is 0 location, right? So your R becomes 0. You have increased your R. Previously it is -1. You have increased your R. But once if the element is inserted, you should initialize your, okay, front also. Okay, your front and rear, right? Your front variable also with 0. So in the starting, one element is inserted, your front is 0 and R is 0. Okay, that is the element. You just keep in your mind, so that I am going to do the same logic in the while implementation. Now, if you insert the second element, you try to understand. Now you tell me, after inserting the second element, what is your F value? Now 10 is there, okay. Okay. Now which is incremented, either rear or F? Now we have given 10 and 20. This is 0 index, first index. But your F is pointed to only 0, but whereas your rear is pointed to 1, right? That means what? Your rear equal to 1. Rear is increased. Why? Because insertion will be take place at the rear end. So R value becomes 1. R becomes 1. And then, okay, so R, if you insert second, then 30, then R becomes 2, then 40, then 40, R becomes 3. Okay, this is 2, 3. Okay, finally, what is R value? 3. R value 3, nothing but what? When is your Q is full? R value 3. When is your Q full? Your rear equal to, okay, n minus 1. Size is 4 elements, right? 4 minus 1. Then your Q is full. Okay, if R equal to n minus 1, then what you can say? Your Q is full. If F equal to R, here F equal to R and -1 and -1, then you can say your Q is empty. Why I'm saying when is empty, you can't delete. When is full, you can't insert, right? That is the logic. Okay, fine. Fine. Let's see, same. Okay, I'm just increasing the rear equal to rear plus 1, and I'm going to insert the value into the rear whenever I want to insert the element into the Q. Okay, and rear equal to maximum size -1, it is overflow. That's it, very simple. Yeah, now you want to display. How you can print? You want to display. Previously you are printed using the top, that means I equal to top and less than or equal to 0, and then print. Now from where you are going to print? Front to rear. Okay, so what is your I value? Starting is front. While printing, what is your for loop? I equal to front, right? I equal to front. Okay, front to rear you want to print, right? I equal to front. What is the condition? I less than or equal to rear. I less than or equal to rear. Okay, then I will increase. While printing, from the front to rear you want to print. Say for example, after that you have deleted 10. Now your front is incremented by 1. Now where is your front? Your front is 1. Now you have how many elements? 20, 30, 40. So wherever front is pointed, that is the starting element, right? Front 20, rear is 40. That's why 20, 30, 40 will be printed. Now after deleting, now your front is pointed to 30. So front is pointed to 30 and rear is pointed to 40. That's why you can print 30 and 40. Likewise, are you clear? So how you are going to display? Initial value front, ending value is rear. So in the for loop. So in such a way, you are going to, and then followed by plus plus, right? Like this, I'm going to display. Okay, this is the display. This is the deletion and insertion. Now let us move with our program. Same like menu driven program we are going to do. Okay. Same, let us run with menu driven program. Yeah, so quickly I'll run this program. Queue implementation using array. Same program like hash include stdio.h. If any exits and any functions if you are using, sometimes I may use exit of 0, it is required or not required, std lib.h. And see, I can also define maximum size of my queue. Max size, how I can define 5? You can define 5, 10 or something. What are the functions I want to insert? I want to use insert, delete, display, right? Any name you can give push pop also, but in the queue I'm using insert, delete, and display. Any function name you can give, okay? For insertion, deletion, and display. So as I told you what is the first and front and rear. What is the front and rear? This front is -1, rear is -1. Initialize. This is starting initialization of the queue. Okay. So I'm going to do the same. Int front equal to -1, comma, rear equal to -1 for initialization of my queue. And int, what is my queue? Earlier I given queue of 100 like that. Now I can give max size. So what you can increase whatever you want your size. Okay. So I mentioned max size is 5. Okay. And then I will start my main program. Okay. And void main. And I will take in choice. Same. I hope everybody know about this similar program like stack. So simply I will move ahead while choice, any model you can give. Otherwise you can also give while of 1. Always it is true. While of 1 is also always true. So I can also give choice value initially 0. Choice equal to 0. Same, all right. Like printf, what are the operations? \n1 insert \n2 delete \n 3 display \n 4 exit \n. That's it. Then printf \n into your choice. Okay, I'll read the choice. Scanf %d, I'll read into the variable choice. Into the choice. Okay, and then switch cases, right? Switch off choice. Switch off choice. The case 1 I'm going to use. Okay, if you have multiple things, you can use braces also. Otherwise, not required. Simply I can say insert, I can say break. Okay, case 2, delete operation, delete function I'm using, we can say break. case 3 and display function, you can say break. Case 4, you can say exit of 0, break. Default, what is your default? Enter valid choice. Printf, enter valid choice. That's it. Okay. I'm using done with the switch cases. And then, yeah, my switch case is over, my while is over, and I came out of main. Okay, in the outside of the main, I'm going to write void insert. How I'm going to do insert operation, right? Simply I can say I'll read one variable item. Okay, I can say enter the element. Enter the element. Whatever the element you want to insert, right? That I'm storing into the variable called item. Okay, fine. After inserting, see, as I told you, what is that maximum, whether your queue is full. See, if rare equal to, okay, 0, 1, 2, 3, that means what? R value 3, nothing but R equal to n minus 1. N is the maximum size. If R equal to n minus 1, what you can say? Your queue is full, right? Same condition I'm writing here. Same condition. If your rare equal to, what is your maximum size? I mentioned here. This is my maximum size is the variable. Okay. So rare equal to max size minus 1. Okay. If rare equal to max size minus 1, I can say my queue is full. I can say my queue is full. Printf expression overflow. Done. So what is another condition while inserting? Okay, if front equal to -1, rare equal to -1. That is first time. First time what I said, your front equal to -1 and rare equal to -1. In case of first time, as I told you, I want to make it as a 0. My front equal to 0, my rare equal to 0. That is my first condition. Next time onwards, my control will come to here. Else, what I can say, rare, always rare should be increased, right? Rare equal to rare plus 1 while increasing. Now in that rare, I want to store. What is your array Q of rare? Where you want to store? Q of rare equal to item. So after increasing the Q, then I'm placing my item into Q of rare. So this is my Q. What is your location? Whatever your rare pointer. Okay. Simply I can say printf value inserted. Okay, after inserting, I can show only one thing, but you can't able to understand. You should until unless you are displaying. So now I will do void display. After that, we can do the other thing. Okay, what I'm going to do now, I'll write void display. How I'm going to display? As we discussed, rare equal to -1. That means what? If your rare is -1, nothing but no element in the queue. So that is printf queue queue is empty. Okay, you can't delete when the queue is empty. Else you need to display, right? That is for displaying purpose. Okay. Else queue elements are, you can display something message like queue elements are, yeah, how I'm going to display in the for loop. Just now we have discussed for I equal to friend, I less than or equal to rare, I plus plus. This is what we have discussed, right? Yeah, for I equal to friend, I less than or equal to rare, I plus plus. Yeah, I didn't put any semicolon for the while. Hurry. Yes, for while we should not put semicolon, my dear. For do while it is there, not for the while. Okay. The for loop, how I'm going to print? Simply I can print f %d \n comma q of I. Q of I, that's it. So that is for insertion and display purpose. Now how can we delete? Okay, let me complete the deletion also, and then I'll show you the execution. And then while coming to the deletion, and before that, if I'm not using this, what will happen? It will throw something error. Let's see. Q2.c. So now I'm not writing other things, only I written display and insert. I want to check it once. Yeah. Options to delete. Here also did I mention the same? Yeah, that's what. So delete I have not written, right? That's why we got the message called unreference. Okay. So otherwise what you should do, you should comment the delete, then you can run it. So now, okay, what I did here, I did not write. So that's why, so from here it is showing you have not completed delete. Okay. So no problem. Instead of wasting the time now, time is running out. So I will show this way and I will run the program also now. So let me run this program and I will show you the execution tracing of this program. Now I'm going to run this. Yeah, see here, this enter your choice. Enter your choice. So I want to insert the element. So now choice 1, enter the element 10, and again value inserted. So the message value inserted. Again, insert an element 1 and 20. Now how many elements we have inserted? 2, right? So what shall I do now? Display. Third option is display. Let's see. See, do we got the whatever you have inserted 10 and 20? Yes, we got. Okay. And also, what is the maximum size? All the conditions you should check it. Maximum size 5 you have given. Okay. All the elements 5. More than 5 if you give, you should get overflow. Let's see whether you are getting or not. See, you should check all the things like overflow condition and underflow condition. Okay, when the queue is empty, you try to delete. When the queue is full, you try to insert like this. So maximum size is 5. So what you should do, I'll try to insert some more. 1, 30, again 1, 40, okay, again 1, 50, again 1, 60. Okay, see, after entering 60, see what is the output you got? Overflow. That means what? Your maximum size is 5 only. That's why 60 is not allowed. Now you see display. You just press 3. How many elements you have? Printing values are 10, 20, 30, 40, 50. So, but we can insert only 5 elements. Can you insert one more element? No. Then you will get the output. Okay, immediately you will get the output. Overflow. Are you clear? Now, you want to delete the element? Choice 2. Yeah, value deleted. How do you know whether it is deleted or not? Let's see display. Now, see, first in, first out, 10 is deleted. Have you observed that? Whatever the first is, okay, inserted, that is deleted. Now, again, if I use the delete, which one is deleted? 20 will be deleted. Let's see. Now, I selected 2. Okay, now, when you say 2, it is deleted, but do you know? You don't know. How can we say? When you display the content, then you can understand. Are you clear? 30, 40, 50. Again, I will say 2 deleted. So 2 more. Again 2. Again 2. Okay. So now you see. Okay. Empty queue. See, when you're trying to see the content, nothing is there. What is that? Empty queue. Here, when it is an empty queue, you are trying to delete again option 2. What is the message you got? Underflow. These are the options is very important. Now, whenever your queue is empty, but again you are trying to delete by selecting the option 2. So you got the message underflow. Fine. Lahari, after getting the output as an overflow, again when you try to give the input as 1, yeah, again it will ask the value, again it will show it is overflow. Again you try, again overflow, again you try, again overflow. Okay, that means it is showing always overflow. Like that. Even when you get underflow, you try to delete, you will get underflow. Like that. That will be repeated. That means always your function is encountering the same. Are you clear, Lahari? Yeah. Yeah, I'll give you the material and everything. Fine. Now, yeah. Now the last option is exit. Fine. Now, shall I tell you like tracing? Yeah. So for your better understanding, okay, for this, I'll give you some kind of tracing. Okay. So how you are going to check in this program when you will get full idea about this program? Yeah. Let me try. Okay, the same thing you should follow at home also. Don't save. Fine. You just keep aside your program. Okay, for any program, you should practice like this. Then only you can understand clearly. I'm just keeping aside of these two. And now you start this program execution. Okay, your program will execute from the main and enter the choice. Okay, so let's assume you already given the choice is 0. Okay, you enter the choice 1. In case of choice 1, it is insert. Your control where it is move, directly it will move to the insert, where here it will ask enter the element. Okay, then it is asking item. Now tell me, okay, what is there in the variable item? Yes, see, in the variable item, okay, let's assume you have given 10. Okay, fine. Now, rare equal to max minus 1. So, what is your rare? And what is your max minus 1? Okay, actually, what is your rare? So, you see what is your rare? Rare equal to minus 1. Rare initially minus 1. Front is also initially minus 1. You should write like this. Then you can understand everything. What is your max size? 5. Okay. Now, is your rare value is minus 1 is equal to max minus 1? That is 4. Okay. 4. False. Rare equal to max minus 1. Okay, it is not true. That's why it is not overflow. It is empty, right? Now coming to if front equal to minus 1 and rear equal to minus 1. Yes, front is minus 1 and rear minus 1. Now what happened? Your front and rear becomes 0, 0. Yes, you just keep front and rear becomes 0, 0. Yes, now over, right? I won't go to the else. Now coming to Q of rare equal to item. Where is your item? Where is your item? 10. Q of rare. Rare value is 0. So Q is what is your Q? It is your array, right? Q is an array with maximum size 5. Okay, Q is an array. Okay. Yes. Okay, which has some index. Q an array. Q of 0. What is your rare? 0, right? So what is Q of 0? This one. Here you are placing item. What is your item? 10. So first you kept Q of 0, the value 10. Now value inserted. This is your output. So after inserting first time, it is closed and then over, your insertion is completed, right? So using the break, you will come out of this program. That's it. Okay. Now again, it will you will come out and your loop is there. Again, you are checking option. Okay. Since it is you are using same enter your choice. Again 1. Again you have inserted 1. Again control will see here. Again 1. Again your insert. Again your item is having 20. Enter the element, it will ask, right? You have given 20. Now, is your rare equal to max minus 1? No. When you will get the rare equal to max minus 1, you tell me. See, when is the full, assume that it is the 4 elements you have. 10, 20, 30, 40. 40. And your maximum size is 5, right? Assume it is another 50 also. Okay. Yeah. So always, okay, let's see now. Later we'll see. Now, what is your R? At this moment, your front end R both is 0 only. Your front end, rear is both is 0 only. Okay. Yeah. Now, after the second element, right? Now we are in second element. Is the front equal to minus 1, rear equal to minus 1? No. Both are 0. Both are 0. Then else. Yeah. What happened here? Rear incremented by 1. What is your rear? Rare becomes 1. After rare becomes 1, your item want to store into the queue of rare. So in the queue of 1, where is your queue of 1? This is in the queue of 1. In the queue of rare, you want to store your item. So now 20 will be inserted here. Okay. Now what is your rare? 1. Then like this, for the second element, your rare value is, for the second element, your rare value is 1. For third element, your rare value is 2. For fourth element, your rear value is 3. For fifth element, your rear value is 4. Now I'm asking your rear value equal to next time whenever you are trying to insert, your rear value 4 is equal to max minus 1, 5 minus 1, 4. Yes, true, right? So that's why at the time you got the overflow. So after your array is full, after your queue is full, okay, that your rear is 4, okay? So rear equal to max minus max size minus 1, your max size is 5. 5 minus 1, 4. Then whenever your rear equal to 4, you will get the message. When again you're trying to insert, okay, at the time it will check the condition, you get the message called overflow. Are you clear about the overflow? This is the way you are inserting the data. Similarly, you try to insert the other elements. Yes, Lahari is asking overflow. Again you give one. Again you give one. What happened? Tell me. Again after insert, again it will ask enter the element. It is 60. Is your rear equal to max minus 1? Yes. Always rear value is equal to max minus 1 now. That's why again it will show overflow. Again you select one. Again enter the element. But your condition true, you are getting overflow. Are you clear like this? Yeah. Like this, you are getting insertion. Okay, when you delete, now you see the delete operations. When you delete, okay, your friend equal to minus 1. When is your friend equal to minus 1? Whenever it is empty queue, starting, whenever your empty queue, friend equal to will be minus 1. At that time you are trying to delete, you got the underflow. Yes, if not, second time. Second time also, your queue of the friend, once you have the data, so now you tell me this time, your friend is 0, okay, rear is 4. At this time, how I'm going to do? Yeah, queue of friend. What is the queue of friend? Friend value 0, right? Friend value 0. So queue of friend is 10, stored into the item. Okay, is friend equal to rear? No. F equal to 0 and R equal to 4? No. Then coming to friend plus plus. Now my friend is move to here. Now my friend, I'll put F equal to 1. That means while you are displaying, you are not deleting. Deletion is nothing but what? You are just moving your pointer to here while displaying from the front to rear you are displaying. That means you are neglecting this. You are not printing. That is the simple concept. You are not removing the data. Removing is nothing but what? First you are pointing the 0 location. After that, your pointer is moved to first location while displaying from the F to R you are displaying. Nothing but this 10 is not displaying. That's it. That is the simple concept of deleting. Okay, we are not applying any other removing functions. Okay. Similarly, you try to display. Now you try to understand the display. Okay, see here. Is your rear equal to minus 1 whenever it is empty, no data, right? So otherwise, what happened? Tell me. After deleting, what is F? F equal to 1. What is rear? 4. You want to display 20, 30, 40, 50. Now see, I equal to front. Front is more than 1. Okay, I less than or equal to rear. Rear equal to 4. Condition true, print Q of 1. That means 20. Then 30, 40, 50. Then it will be come out of the loop, right? That means whenever the values are printing from the front to rear. Okay, this is the way we are displaying in the queue. Okay, in the stack we are printing top. Okay, based on the variable top. Fine, that's it. Okay, now the queue operation is completed. So now in the next class I may explain about only one queue, that is circular queue. After that, yeah, you try to understand the beauty here. You try to understand the beauty here. The disadvantage of the queue, I'll tell you. Okay. See, for example, your rear pointer is 4 when here data is there, here data is there, here data is there, here inserted, here inserted. So now your rear is 4. Your rear 4, nothing but what? Is your data is full or not? Your queue is full. Rear inserted, here data is there, here data is there, here data is there, here data is there, here data is there. Now is the queue is full or not? Yes, queue is full. Once the queue is full, your queue is full, okay? But after that you delete it. After you deleted 3 elements, what is your friend? Okay, 0, 1, 2, right? Yeah, after that your friend will be becomes 3. And then you have some elements empty space, but queue indicating it is, your key is indicating it is full. But is it full actually? You have some memory. So my dear students, you try to understand very carefully. Okay, since your rear is showing the ending, it is saying that your queue is full. After that, I deleted some more data, but still, as per my output, based on the rear, it is showing full. But you have some spaces. Okay, that is a disadvantage of the queue. That is the disadvantage of linear queue. So far, we are using linear queue. After deleting, your front values will be increased, but your rear value is ending only. It is showing that your queue is full, even though you have sufficient spaces. That is the disadvantage. To overcome this advantage, I just make it round like this. 0, 1, 2, 3, 4. Now you see, you have 1 and 2 at third and fourth location, but since it is a circular queue, it is showing some more data. Now you can insert, okay? But it will not show the queue is full. But the disadvantage of in the linear queue is, after inserting everything, a rear is incremented, rear is ending, but the front is having some empty space, but also the queue is indicating full. That is a disadvantage. Are you clear? To overcome those disadvantages, I am going for circular queue. How can we do this circular queue? The implementation I can show you in the next class. After that, we will move to the linked list concept. Okay. After that, we'll move linked list. These are the one by one operations. I'll tell you in the next class how this linear circular queue will do. Okay. Till then, happy learning, and you practice whatever you have discussed, stacks and queue implementations. Thank you very much.
Thank you, sir.
Yeah, thank you, ma'am.